Question 2. Displacement time graph of a moving particle is given in figure. Instantaneous velocity of the particle is negative at the point. Okay. So what is the concept you need to know to solve this problem? Fine. If if you have a graph, any graph, this is y and this is x, y equals to a function of x. Okay, that means maybe when you plot a graph between x and f of x, might be this is your plot. Okay, if I want slope of the tangent at any point, how do you find? Yeah, you draw a tangent. What is the angle made? And tan of that angle, you call it as slope. Fine. But there is another way to find the slope. It's directly if you find dy by dx at that point P. If this is P, at that point P, find dy by dx and substitute a value of p x comma y, you get slope. So this is another way of writing slope at point P. That is ultimately you will get equals to tan theta. Okay, so in our graphs, maybe displacement time graph or maybe velocity time graph, you use this concept very frequently. So let me explain this particular point. If you have a velocity, a displacement time graph, and say you have, maybe this is your graph. So what will be velocity at this point? If I ask that question, maybe for a while you just pause and let's find the slope, dy by dx. So here y is dx, y is x is t, and dx by dt equals to what? V. So slope of the tangent at any point P, slope of the tangent at any point P gives velocity. This is how slope of the tangent at any point P gives velocity. So in our figure, if you see, the graph, it's given like this. Okay, so this is your E, and if you notice at point C, at point D, and at point F, and if you draw the tangents over there, so this is your tangent, maybe, and this is your tangent, and this is your tangent. So what are the angles made by this tangent? This is the angle theta 1. Here its angle made is 0. Here the angle made is maybe theta 3. This is theta 4. So we can understand intuitively that theta 3 is clearly greater than 90 degrees and of course less than 180 degrees. So that means tan theta 3 lies in second quadrant and in second quadrant tan theta equals to negative. But we have seen slope at any point also gives velocity. So this is also equals to velocity at E. So that is how you get velocity at E is negative. And that's the only point where particle is having a negative velocity. And yeah, in the given options you see F is repeated 2 times. Probably he must have intended to give one F as A. So if you are able to solve this answer, like if you are able to get E as your answer, so you need not worry. And for those who couldn't get E as the answer, please try to learn this concept. Thank you.